So now let us also see how to program the remote part of the project. In the last part of our coding, we have saw how to program the gesture control car. Now let us see how to program the gesture control remote part of it. So here majorly we are using a IC called as MPU 6050. This IC has two sensors inbuilt. One is accelerometer and another one is a gyroscope. So these two sensors will give totally 6 values. So this particular MPU 6050 is also called as a 6-axis microcontroller. So we have a microcontroller inbuilt also in this particular IC MPU 6050, and from that microcontroller we are going to communicate back to the Arduino saying that these are the values of yaw, pitch and roll. So that is nothing but, in simple terms, X, that is forward and backward, Y, and the up and down is nothing but the Z. So this is called as yaw, pitch and roll. So these values will be like given to the Arduino Nano. So these values, how it will come to the Arduino Nano, it is based on the I2C protocol. So I2C is a very simple protocol where a serial communication will happen from the sensor to the Arduino Nano. So this is how it is going to happen. So let us see the coding part of it. For this we have included the library over here, as you can see, and we should also include the I2C dev.h as one of the other library where it will help us to easily communicate to the Arduino Nano. And once we import these two libraries, this is the implementation part of this. We have Arduino wire. So what is that Arduino wire? Arduino by itself has a kind of a communication channel where it will transmit the data from the sensors and to the microcontroller. So we are trying to equate them both, and we are also including the wire.h over here. After all this, the main part of our code is here. So this is the serial communication part where we are trying to configure, we are trying to set the roll, yaw, pitch and roll. We are trying to configure yaw, pitch and roll, these 3 axes, and we are setting some threshold values to them like this. Over here you can see we are setting some threshold values. If it is like, if the MPI is like more than -25, means if the x axis is like going below, when you can see like positive and negative of the x axis. So the negative x axis over here, this side, which is like this, in this particular sensor it is like this. So this is the negative value. So whenever I am getting the negative values from the sensor, I need to move forward. That is nothing but my gesture is like forward. So for that reason I am passing a character called as F to my other Bluetooth, which we have saw earlier, right? So to that Bluetooth, to the slave Bluetooth, we are going to send this data. And similarly with the different axes, like if it is a positive value in the x axis, that is nothing but our backward, that is B, and towards right it is 20. I have set a value of 20. We can also set it a little more also. So if I am passing that, that is nothing but right, that is on the y axis like this. Then like this, if I just do the left, then it is minus y axis, the negative y axis. There I am passing a character called as L. And if I am not passing anything, that means it is like S, that is nothing but stop. In the functions we have saw already. So S means stop. I am stopping all the motors. So that's the part of the programming end with respect to this gesture control remote part. And here also you can see the BT serial. So the BT serial has begun with the baud rate of 38,400 here. So in the last part of the code we saw the BT serial was again 38,400, and here also it is 38,400. So both the baud rates are similar so that they can communicate each other very easily. And why have just turned on this as 1,15,200 baud rate is in the serial begin. That is all because I am already using one of the channels for communicating or transmitting the data from one Bluetooth to another Bluetooth. That is nothing but here I am using a master Bluetooth. In our remote control car, I am using a slave Bluetooth. So the master will always give a command to the slave. So that's why both the baud rates will be similar. But I am also using one of the serial begin, that is because I want to read the input from my sensors also, right? So I need another channel. So for that reason, I am also using a different baud rate. So now it's time for us to upload this code to our microcontroller. So let us see how to upload it. So again, before uploading the code, we need to take out the Bluetooth. We should not upload the code by connecting the Bluetooth, because the Bluetooths will be like configured priorly, and if we upload the data, then the configurations of this Bluetooth will be like disturbed, and they will get resetted to the default values. So that for that reason, we should not connect the Bluetooth while uploading the code. You can see here the board is Arduino Nano. It's already been like selected in the tools, and also so I'm using Atmega 328 old bootloader to upload the program to this particular Arduino Nano. So after doing this, let me upload a sketch. So usually Arduino programs are also called as Arduino sketches. As you can see, the program is getting uploaded, and our program is using so much of bytes for the storage space, and maximum of storage space that we have in our Arduino Nano is like so much, as you are seeing here. So our sketch is using 16,984 bytes of data to store this particular program, but maximum of 30,720 bytes of bytes of memory location is available for us to store the program in our Arduino Nano. So we have completed uploading the code to our remote part of the gesture control robot, and finally it's time for us to see the working of it.